So in the last video, I have shown that how we can generalize the surface integral, the double integral into the surface integral, and therefore we can find out the surface area of any kind of surface which is situated in the space, and the figure will be like that. In this way we can say that the volume integral is the generalization form of the triple integral. So as you know that surface integral is the generalization of the double integration, so therefore we can say that the volume integral is the generalization of the triple integral. Now we will move on to the topic how we can find out the line integral. So we will now elaborately will discuss about the line integral, how to find out the line integral. So for that we have to consider a space curve r bar equals to r of t, where t is the parameter which denoting the arc length s of the curve. So if I will take a curve here, so therefore r vector equals to r vector of t, where this t actually nothing but the parameter of this particular curve, and t is which is actually what it is denoting. It is denoting the length of a particular portion of the arc, and that is must be denoted by s. So therefore the curve can be, so I am considering therefore that r vector equals to r vector of s, because actually t is representing the arc length, so we can say that r vector equals to r vector of s. So it is a function, actually the function of the arc length, and that is s. And we have to know that one more thing that is dr vector, ds is the unit tangent vector, and which is denoted by t vector. dr ds, if I wanted to find out the first derivative of r vector with respect to s, we can get the unit tangent vector, that is t bar, which is actually denoted by t bar. Now we are considering a and b be 2 points on the curve r vector r of t, corresponding to t of a and t of b. So if this is my curve, so here if I can take a point a, here I can take a point b, and this is actually, therefore this a actually t equals to tsa, and this equals t equals to tbsa. Where, so therefore now if dr dt is continuous for ta less than equal tb, then the arc AB is said to be the regular arc. If this portion is continuous, if the dr vector dt is continuous, then we can say that this curve will be a regular arc. Particular this portion is a regular arc. Now you have to know that what is double point. A double point on a curve is a point where the curve intersects itself. Like if I am taking a particular curve which is like this, so here this curves, if the curve is started from here and it is again bending and it will intersect at this point, again it will bend here and again it will intersect at this point, then I am getting double point here. So double point is not only that it will cut only 2 points, it may vary. That means it will bend and again it will cut at this point. So therefore I can say that a double point on a curve is a point where the curve intersects itself. So therefore this point should be said double point. A regular curve is a curve where consisting of a finite number of regular arcs without double points. Like in a regular arc or a particular curve said to be regular curve, if there will be no double points, like a curve should be this way, that means no double point will arise here. It will not bend, it will not again intersect itself. So therefore it will be continuous like that. So if I will get any kind of curve like that, that curve will be said to be the regular curve. So obviously a regular curve will be consisting of regular arcs. Now you have to know the definition of the line integral. Line integral actually represented by gamma. So let gamma is denote the portion AB of the regular curve. So therefore here I can say in this way that if this is my curve, so particular this portion AB is said to be gamma. That is a portion, particular portion on the curve, and that is denoted by gamma here. So therefore gamma denote the portion AB of a regular curve R vector equals to R of S. As you know, we can represent any curve in this way, corresponding to the range SA to SB. SA to SB means what? S is the arc length and SA means the point A, from the point A to from the point B. So this is actually denoting the range of arc length. So S is denoting the range of arc length, and the range of arc length will be from SA to SB of the arc lengths. Let there exist a vector function f vector. Obviously I need a vector function to do the integral. So because you know that f vector dot ds integration over gamma, that is actually representing the line integral. So then obviously I need a vector function for that. So let there exist a vector function f vector defined at all the points of gamma. The component of f vector along t vector is f vector dot t vector, and that is denoted by ft. For different points on the curve, ft is the function of s, and this one SA to SB ft ds equals to integration gamma. Actually gamma, what is gamma representing? Gamma representing the portion of the curve, and the portion of the curve is nothing but from SA to SB. And as you know, ft is what? Ft is the component of the function f along t vector. So f dot t vector, f dot t, I can easily write f dot t ds. That is equals to f dot dr. Why dr? If I wanted to write dr in this way, dr ds, if I wanted to write in this way, then dr ds is nothing but the unit tangent vector. Dr ds, as I already mentioned, that dr ds is t vector, which is a unit tangent vector. So t vector ds. So here I can get this expression that f vector dot dr over the gamma, that is actually the representation of a line integral. Therefore integration gamma f dot dr is called the line integral of the vector function f taken over gamma. So in this way, we are getting the formula how to find the line integral. So in this way, by this formula f dot dr over the gamma over a particular portion of the curve, if we do the integration, then we can easily get the line integral for the function f.